Hi guys, welcome back to my channel. This is the final question in a 2019 CXCK Pure Mathematics Past Paper 2, Unit 1. And it says, it's question 6. It says, by using the substitution u equal 1 minus x, determine the integral of all of this. Now, of course, if I'm going to use the substitution, certain things have to change, right? So if I'm changing to u, dx has to become du. So what do? U is equal to 1 minus x. I'm going to have to go and find du over dx, which is going to give me negative 1. So du equal to negative dx. So we can say that negative du is equal to dx. Alright? We can start by putting in that part right away. So you have x u squared times negative du. Now, why is it that I put a bracket around the negative du? Because I don't want to create the impression that it's a minus du. Alright? We're actually multiplying here, and that's the impression I want to create. So what I'm going to do, I'm going to take the minus sign outside. So I have x u squared du. Now I still have a problem because we still have an x in there, right? So we're going to have to go back to the 1 minus x, the substitution, and find it in terms of u. So I can say that, here we go, if u is equal to 1 minus x, I could simply take x over and bring the u over. So x equal to 1 minus u. You sub that in, so you have minus the integral, open bracket, 1 minus u times u squared du. Now, notice that we have a product here. Alright? Now, some persons might be saying, how am I going to integrate this as a product? No. We don't need to find any way to integrate a product if we can simply expand the bracket. So you have a u square out there, you multiply out the bracket. So you have u square minus u cube du. Alright? So we don't use any form of product integral or recognition or substitution whenever we can simply expand. So this becomes negative. If I integrate u square, I'm going to have u cube over 3 minus u to the 4 over 4 plus the constant of integration, right? I might want us to tidy this, write this in a better way. So what I could probably do here is multiply out by the negative. So I'm going to have negative 1/3 u cube plus a quarter u to the 4 plus c, and probably put that in descending order of power. So you have a quarter u to the 4 minus 1/3 u cube plus c. And that's how you get your 5 marks. But I'm not completely finished as yet, because bear in mind that u was equal to 1 minus x. Alright, so this becomes a quarter 1 minus x to the 4 minus 1/3 1 minus x all cubed plus c. Alright, and I can actually make this simpler. I can make this simpler by factoring out a 1 minus x to the 3rd power and simplifying it as far as possible. Right? So you could go right ahead and do that. Alright, so normally you want to break it down as far as possible to get your maximum marks. But I'm going to move to the next question. And this is question B. This is an interesting question. It says that f of t is equal to 2 cos t and g of t is equal to 4 sine 5t plus 3 cos t. Show that the integral. Alright, so we want to show that the integral of f of t, which is going to be f of t is 2 cos t plus g of t. G of t is 4 sine 5t plus 3 cos t dt is actually equal to the integral of 2 cos t dt plus the integral of 4 sine 5t plus 3 cos t dt. Alright, so what we're going to do, we're going to take the left hand side first. Let's break this down. We're looking for like terms. You have 2 cos t, 3 cos t, that's going to give me the integral of 5 cos t plus 4 sine 5t dt. Alright? Over on this side, we can go right ahead and start integrating. When you integrate cos, you get sine. So I'm going to have 2 sine t plus, if I integrate 4 sine 5t, I'm going to get, well, let me take out the plus sign because that's going to give me a negative now. So when you integrate sine, you get a negative cos, alright? So I'm going to get a negative 4 cos 5t. And of course, I'm going to divide by the differential of a 5t, which is 5. So over 5. Plus, when I integrate cos, I'm going to get sine. So I'm going to have 3 sine t plus a constant of integration c. Alright, let's wrap this up. Over on this side, if I integrate this, integrate cos again, I get sine. I'm going to have 5 sine t plus, of course, integrate sine 5t. You're going to get negative. So let me put that there. The integral of sine is negative cos. So I'm going to have negative 4 cos 5t over the differential of a 5t, which is 5 plus c. Alright, good. Over on the side, you can see like terms. So 2 of that and 3 of that would give me 5 sine t minus 4/5 cos 5t plus c. Whoa. LHS equal right hand side. Good. So that's exactly what we wanted. And that's the end of that question. We have shown that the two sides produce the same result. Alright. Now it says calculate the volume of revolution formed by rotating the region enclosed by y equals sine x, x equal pi over 2, x equal pi, and y equals 0 about the x-axis. By the way, let me point out something. This is a function that we should know like the back of our hand, right? Let me just give a quick sketch. I'm just going to sketch the first part here. You should know the function at the back of your hand. So pi over 2 and pi. This is 1. Remember the sine function goes up here and it comes back down there. Now you want the area between x, the area between x equal pi over 2. Alright, let me put that here. This is pi over 2 right at the middle right there. X equal pi, which is right here, and y equals 0. Now, we should all know that y equals 0 is the x-axis actually. Alright, very important piece of information. So I want the area right here. Well, the volume of revolution. So when this is spinned, sorry, I said area, but it should be volume. When this is spinned around the x-axis. So when you spin it around the x-axis, the volume created. Now, there's a special formula for the volume. The volume is equal to pi times the integral between a and b of f of x all squared dx. And this is when it's rotated around the x-axis. So in this case, my volume is going to be pi times the integral between the lower boundary is pi over 2, the upper boundary is pi, the function is sine x. So I'm going to have sine x all squared dx. Alright, let's manipulate this and see what happens. Now, I can go back and say that the volume, alright, let me get back my stronger color here. Volume is equal to pi integral pi over 2 pi sine squared x dx. Now we should know that whenever a trig function such as sine x or cos x has a power, it's going to be a problem integrating it directly. So we're going to have to use the identity. There is only one function that, well, not one function. If it was sec squared, you know, when you integrate it, it would be tan, because when you differentiate tan, you get sec squared. Or if you differentiate cot, you get negative cosec squared. So this takes me to my double angle identity. Alright, that says cos 2x is equivalent to 1 minus 2 sine squared x. Alright, and of course I'm going to have to transpose this identity. I'm going to go down and get some space. So I'm going to have to transpose a sine squared x, alright? So I can bring over the cos 2x, so I can say 2 sine squared x is equal to 1 minus cos 2x. Alright, so sine squared x is actually equal to a half, open bracket, 1 minus cos 2x. Good. So good so far. So let's go back now and plug in everything. So I'm going to have volume equal pi, open bracket, a half, this is pi over 2 down there, lower boundary, pi upper boundary, open bracket, 1 minus cos 2x dx. Alright, now before I even start integrating, you realize that we can bring out the half, put it outside with the pi. So you're going to have volume equal pi over 2, all constants can go outside, integral 1 minus cos 2x dx. Good. Now the integral of 1, of course, is just going to be x with respect to x, and the integral of cos 2x, don't forget your boundaries, alright, which are pi over 2 and pi. Alright, so we go right ahead and integrate that. That's no big thing to integrate. So my volume, so the identity is the important thing. My volume would be equal to pi over 2. I integrate 1, I'm going to get x. I integrate cos, I'm going to get sine. So I'm going to have minus sine 2x over 2. Of course, we have boundaries, so we don't need a constant. So this is pi over 2, and this is pi up here. Good. Now, I can go right ahead and put in the upper boundary and subtract when I put in the lower boundary. Right away, without hesitation. So I'm going to have volume equal. Now, I don't need to write the pi over 2 twice, so I'm going to create an extra bracket, right? Pi over 2, I factor that out. I'm going to put in the upper boundary, which is pi, so I'm going to have pi minus sine. If I put pi in the place of x, I'm going to have sine 2 pi all over 2 minus, so I need a little bracket here now. I'm going to put in pi over 2 in the place of x. So I'm going to have pi over 2 minus sine 2 times pi over 2. I'll put the bracket there. Over all over 2. So volume equal pi over 2 out here. Alright, let me make sure I have this written properly so I don't make any mistakes. Alright, so volume equal pi over 2. Alright, let's see what's going to happen in here now. I'm going to get pi here. Now, sine 2 pi is 0. So that's gone totally. Alright, minus, if I clear this bracket, I'm going to have minus pi over 2. Alright, what is going to happen here? This is going to be 2 times pi over 2, which is pi. But we know that the sign of pi is also 0. So that's gone. So my volume is really pi over 2 times pi minus pi over 2 is really pi over 2. Good. So my volume now becomes, let's see, pi square over 4. And of course, you need to put on units. So it's cubic unit. Alright. That's the volume. Very neatly done there. We'll leave it in terms of pi, because that's the exact value. Alright, we're almost there. Now part B says solve the differential equation. Alright, clearly this is what we call a separable differential equation, which means you can put it in the form. Let me just give you the form f of y dy is equal to g of x dx. So once you can get it in that form, it's separable. And at this level, you're not tested so heavily on differential equations, so that's typically the kind that you get. Alright, to make that work quickly, we just simply cross multiply. So I'm going to have y dy equal x root x squared plus 1 dx. Alright, and we apply the integral. Alright, let's go. If I integrate y, I'm going to have y squared over 2. Bear in mind, we're not going to put a constant on both sides, because a constant is a constant. We just need one of it. On the opposite side, there are several ways that I could go about integrating this. Alright, while I'm going to use substitution at the current moment, I could have used recognition. And let me just simply put it over here, that once you're integrating a function, the integral of f prime of x times f of x to the n dx is simply equal to f of x to the n plus 1 over n plus 1 plus c. Alright, and you might be asking, how does this apply here? Let me just quickly show you. You have x here, you have x squared plus 1 here to the half dx. Now, first of all, examine the bracket. You can realize that n is like a half. The function raised to the power is x squared plus 1. The differential should be outside for you to apply this recognition. But look at the differential. If you differentiate x squared plus 1, you get 2x. Now that is good, because guess what? You can always put a constant here and put a half outside to balance it. So when you integrate all this, it becomes a half. You take the function with the power and you add 1 to the power. Alright, so it's going to become x squared plus 1 to the 3 over 2 over 3 over 2. Whenever you divide by a function or a fraction, you multiply by the reciprocal. So I'm going to multiply the numerator by 2, the denominator by 6. So I'm going to have 2 over 6 x squared plus 1 to the 3 over 2 plus c. And you break this down to 1/3. Alright, so that is by recognition. If you don't like that, you can go by substitution, where you say let u equal x squared plus 1. You change it to a u function, so you're going to have du dx equal 2x, transposing, so you're going to bring the dx across and 2x over. So du is basically du over 2x is equal to dx. Alright, quick transposition there. So you go back and you make your substitution. Now on the right left hand side, I still have my y squared. So y squared equal the integral of x. U is going to replace x squared plus 1. So you can write it as u to the half times du over 2x. And this normally happens in recognition, some form of cancellation or something. And then the half can go outside now. So I'm going to just bring this down. So you're going to have y squared equal a half integral u to the half du. Alright, where you simply just add 1 to the, so y squared equal a half, add 1 to the power, so you have u to the 3 over 2 over 3 over 2 plus the constant of integration. So y squared is basically equal to 1/3 u to the 3 over 2 plus c. But this is a general solution. You are given enough conditions to find a particular solution. X is 0 when y equal 2. Good. Now let me put back this thing in terms of x. So y squared equal to 1/3 x squared plus 1 to the 3 over 2 plus c. What we're going to do is find c. And let me go back up. So it was x is 0 when y equal 2. Alright, so you substitute that in there. So you're going to have 2 squared. Oh, I think I left out something here. I definitely left out something. I left out the y squared over 2 coming down. So this should be over 2 over 2 over 2. Come all the way down. Y squared over 2 all the way down. Over 2 over 2. So I'm going to have 2 squared over 2 is equal to 1/3. Alright, 0 squared plus 1 to the 3 over 2 plus c. Now here's the beauty about this. 0 squared is 0. 1 raised to anything is 1. So you really have 2 equal 1/3 plus c. So c is equal to 2 minus 1/3. Alright, so c would be 5 over 3. Alright. Now, therefore, the particular solution, I would say, is y squared over 2 is equal to 1/3, open bracket, x squared plus 1 to the 3 over 2 plus 5 over 3. We don't want like this like that, so we can go ahead and get rid of this 2 down here. So say y squared equal 2/3 x squared plus 1 to the 3 over 2 plus 10 over 3. Alright, I would normally write the square, but that wouldn't look so neat. So I'm going to leave it as y squared equal all of this right here. Alright, so you just need to focus when doing these questions. And guess what, guys? That's the end of the paper. Keep the focus, work as quickly as possible, and you'll get the paper done. Alright, so that's the end of the 2019 CXC Cape Pure Mathematics past paper.